All right, and we're moving on with our exponents. So in the first section, to recap, we did the properties of multiplication where we added, we did power to a power, which is where we multiplied. In section 2, we talked about dividing exponents where we subtracted. And we, in both sections, we talked about when you have a power on the outside, how it needs to be applied to everything on the inside. So today we're going to talk about, we're going to define zero exponents and also negative exponents. So to do that, I'm going to go through this chart with you. So hopefully you can start to understand what this actually is going to entail and how this is going to work. So what happens is we have 2 to the n power, and we're just plugging this in for our power. So like 2 to the 4th power is 16. And then we do 2 to the 3rd power is equal to 8. And then 2 to the 2nd power is equal to 4. And 2 to the 1st power is equal to 2. And if you notice what's happening here is as we go through this and we lower it by a power, because the base is 2, we actually keep dividing by 2. So when we do 0, 2 to the 0 power, if we divide by 2 again, 2 divided by 2 is equal to 1, which shows you 2 to the 0 power is equal to 1. And then if we go to negative 1, 2 to the negative 2, which is 1 over 2, or 1/2. So let's look and see what happens when we use the base of 3. So using the base of 3, you should imagine that we're going to be dividing by 3 each time. So 3 to the 3rd power is equal to 27, which actually 81 divided by 3 is 27. 3 to the 2nd power is 9, so 27 divided by 3 is 9. 3 to the 1st power is equal to 3. Of course, 9 divided by 3 is 3. And we have 3 to the 0 power. We divide by 3 again, we get 1. And then negative 1, if we divide by 3 again, we get 1 over 3. So what this does is this actually defines how we can define a 0 power. If you notice, both of them, it equals 1. So that's the first thing we want to talk about is anything, as long as your base is not 0, to the 0 power will equal 1. 5 to the 0 equals 1. A million to the 0 power equals 1. X to the 0 power equals 1. As long as that base is not equal to 0, anything to the 0 power will be equal to 1. Okay? Now with negative exponents, what you should notice here is we didn't keep this table going, but if we did, if I wanted 2 to the negative 2 power, what's going to happen is we would divide by 2 again, and we would get 1/4. Well, that doesn't tell us a whole lot until we frame it like this. 4 is the same thing as 2 to the 2nd power. Over here, if we were to divide, if we did 3 to the negative 2 power, that would equal, we would divide by 3 again, we would get 1/9. And again, notice 9 is 3 to the 2nd power. So what you should notice from this is what we see here is we have a negative 2 exponent. What the answer becomes is it becomes 1 over 2 to the positive 2. So what we're doing is we're essentially taking this negative exponent, we're bringing the number to the bottom of the fraction and making it positive. So 3 to the negative 2, same thing. We brought it to the bottom of the fraction, and now the 2 is positive. And that's what these rules here show you, is that if I have a to the negative n power, that will be 1 over a to the positive n. And then vice versa. If you have a negative power on the bottom of a fraction, that will be like bringing it up to the top and making it positive. So whenever you move it, you're bringing it up to the top, or you're making the exponent positive. Now, you just got to be really careful. The only thing you will ever move is anything that has a negative power. You will never move anything else. So if a number does not have a negative power associated with it, it will stay where it's at. Notice here, 2 to the negative 1 power is going to be 1 over 2 to the 1st, 1/2. 1 over 2 to the negative 1, this 2 comes up to the top, and then the power becomes positive. Negative exponents are one of the most complicated things for students to understand. So we're going to go through some of these examples. We'll go through them as slowly as possible, and obviously we're going to have time in class to work on this as well. So let's see how this works. 6 to the negative 2. Because it's a negative 2 power, I'm just going to rewrite it as 1 over 6 to the 2nd. And you could write that as 1 over 36 if you wanted to. Your calculator will give you that, but I want you to know how to manipulate these negative powers. The negative's on top, so we just bring the 6 to the bottom and make it a positive. X to the 0 power, as we said, will always equal 1. Okay, this one's a little bit more difficult. What we're going to do is we're going to use the previous section rules, and we're going to apply this negative power to each one. So we have 2 to the negative 2 power over 3 to the negative 2 power. Now, as we said with our property, this is where it's really important that you understand what negative powers mean. To get rid of this negative 2 power, we've got to bring this entire thing up to the top. To get rid of this negative 2 power, we've got to bring this entire thing to the bottom. So now, I'm bringing the 3 up to the top, but now that I've brought it up to the top, the power will become positive. When I bring the 2 to the negative 2 to the bottom, the power again becomes positive. So all we're doing is, I don't want you to think of it as flipping it, because if you just think of flipping it, then you might flip the wrong thing. But we are moving this entire portion to the top and making the exponent positive. We're moving this entire portion to the bottom, making the exponent positive. And again, you could write out that that is 9 over 4. It's not really important. It's more important here that you knew how to move them. And then this last one, 0 to the negative 7 power. Well, if you start with 0, that you're going to end up with 1 over 0 to the 7 power. That's very important. You cannot have 0 on the bottom of a fraction. So this right here is actually undefined. So you cannot have 0 to a negative power because it brings the 0 to the bottom of a fraction, which is undefined. Okay, so you have 4 to try on your own. So try those. Take a couple minutes to do that. Hit pause on the video and then just hit play when you're ready to look at the solutions. Again, try them on your own so you can see if you understand this or not. All right, so this first one, you have something to the 0 power, it should just be 1. I mean, it's easy. 2 to the 0 power, 3 to the 0 power, both of those are 1. 1 over 1 is 1. Second one, we have negative 8 to the negative 2. So what we do is we bring that to the bottom of a fraction. So if there's nothing on the top already, then it has to be 1. Whatever's left over would just be 1 because there's nothing to leave there. So it's negative 8 to the 2 power. Negative 8 squared is 64. So you have 1 over 64. This one, the 2 to the negative 3, was on the bottom. So we bring that up to the top and make the exponent positive. So we have 2 to the 3rd power is equal to 8. And then the last one, negative 1 to the 0 power. Anything to the 0 power, as long as this portion is not 0, is equal to 1. Okay, so hopefully that makes sense. Let's go on to the next page here. Okay, so these are all the properties we have now talked about. So we're going to try and combine some of these together and see what happens. So this is where it gets a little bit more complicated. So what you want to do is make sure you go through these step by step. Do all of the properties that you know and that you're aware of, okay? And we'll see where we're at. So here we have negative 2 to the 5th times negative 2 to the negative 5th. So what we're going to do is, one thing I want to let you guys know is, once you understand these properties, you want to deal with negative exponents last. So don't do anything with the negative exponents until you're done applying all of your other properties. So here, what we look at is, I have negative 2 to the 5th times negative 2 to the negative 5th. So I will use my initial property of addition. So it would be 5 plus a negative 5. Well, that's equal to 0. So 2 to the 0 equals 1. So there we didn't have to do anything with negative exponents really, because it ends up going away. That's why you don't want to mess around with it until the very end. Okay, here we have a power to a power. So this is 3 to the 3rd power times negative 2. So we get 3 to the negative 6. And again, now we want to do something with this negative power. So that is equal to 1 over 3 to the 6th. So once again, very important. Once you see that negative power, that's when we need to apply the rule to get rid of the negative. The way to do it is to move it to the bottom of a fraction if it starts on top. Okay, here we have 1 over 8 to the negative 2nd. Because it's negative 2nd on the bottom, we will move this entire thing up to the top. So that will just be 8 to the 2nd, which is equal to 64. And again, that 1 just stays there. It doesn't matter. So 64 is your answer, or 8 squared, one of those two. And then this last one, this is a quotient. So what we're going to do is we do 7 to the 3 minus 5, because we're subtracting. So we have 3 on top, we have 5 on the bottom. So there's actually two ways that you can look at a problem like this. We can either use our property of 3 minus 5 equals 7 to the negative 2. So if you have 7 to the negative 2, then we need to change that to 1 over 7 to the second. That's that's using the property. The other way you can think about this is if I write out 3 7s on the top and 5 7s on the bottom, watch what happens when we cancel these out. We are actually left with 2 7s left over on the bottom, which is exactly this. I mean, that's proof right there about our negative exponent property and our division property. So either way works. The subtraction is a little bit faster, mainly because if the numbers get really large, you don't want to write all of these out, but the principle is still the same. The 3 on the top will cancel out with 3 on the bottom. We're left over with 3 on the bottom. That's why it's 1 over 7 squared, which actually equals 1 over 49. But either one of these, for this purpose, is okay. All right, so again, you have some checkpoints to do. See how much of these you can do step by step. Use your properties. Don't do anything with the negative exponents until the end. Hit pause on the video and then just go ahead and hit play when you're ready. All right, so in this first one, we have 4 to the negative 3. You should have brought the 4 up to the top. Make the exponent positive, so 4 to the third power is equal to 64. Second one, we multiply the two powers. Negative 3 times negative 1 is a positive 3. 5 to the third power is 125. Next one, same basis, so we're adding our exponents. Okay, so negative 5 plus 5 is 0. 3 to the 0 is 1. And then the last one, we are subtracting our exponents. So we have 6 to the negative 2 minus 2 is negative 4. Because it's 6 to the negative 4, we're not done yet. We have to get rid of that negative. So we bring that to the bottom of the fraction, which is 1 over 6 to the 4th. Okay, let's look at the next example. So now we're getting into the real complicated problems. If you can do these ones, then you're in real good shape. So the first one, we're going to do, remember, power on the outside will apply to everything on the inside. So 3 to the third power, x to the negative second, to the third, and then y squared to the third. Okay, and then again, we will just simplify these as needed from here. So we do 3 to the third is 27. X to the negative 2 times 3 is x to the negative 6. And y to the 2 to the 3 is y to the 6th. Again, we are multiplying with these properties. So now we do have one negative exponent. Here's what you need to make sure you do. Only move the portion that has a negative exponent. So this will be 27, and y to the 6 will stay on top because they don't have a negative exponent, and the x to the negative 6 will go to the bottom, and then the exponent will become positive. So there's your final answer. Okay, the next one. Again, simplify each piece. Simplify the numbers, so 4 over 8. I'm going to write these as separate fractions so you can see. 4 over 8, x to the negative 2 over x, and y to the 4th over y to the 6th. So 4 over 8 is 1/2. X to the negative 2 over x, that's x to the negative 2 minus 1. So that's going to be x to the negative 3. And then we have y to the 4 minus 6. That's y to the negative 2. Now, keep in mind when you're doing these, the result will always be on top. It will always be on top. Okay, so the result, even if it's negative, will always be on top. So what we're going to do is we're going to bring these to the bottom, so it will look like 1 over 2 x to the third y squared. So we brought both those to the bottom, because they're negative exponents. The 2 stays on bottom. Okay, make sure you do these checkpoints and bring them to class.